So the chapter name is motion in a straight line. Motion in a straight line. Distance, I will tell you, listen carefully. Suppose I am standing at A. I am standing at the position A. I want to go to the position B. This, let A be my house and B be the office. From my office I want to go to, from my home I want to go to office. Suppose let this be the road. Okay, this is the road connecting my house and the office. So how much distance shall I travel? How much distance shall I travel? I will be either traveling in bike or bus or whatever. The distance is actually the path length or the length of the road. Understood? The length of this road is considered as the distance. Distance, this one is said to be the distance. Unit will be meter. The best name corresponding to distance is the path length. In textbook, in problems they use path length instead of distance. They use the term path length. It's very clear, no confusion if we use this term path length. So the path length is the distance, the length of this road, the length of the path. Understood? Now the shortest distance between A and B. The shortest distance between A and B, this distance. This shortest distance is said to be what? Displacement. Clear? If I travel by aeroplane, this will be the path. Understood? This is said to be displacement. The unit is again meter. So I hope you have understood the difference between distance and displacement. Displacement is actually the shortest distance between the initial and starting. The definition is not required. The definition is not required. You have to understand the concept. Displacement is the shortest distance between the starting point and the final point. But the distance is the path length or length of the path. And remember, when we talk about displacement, the direction should be specified. The direction should be specified. For example, 10 meter towards north direction. When we talk about displacement, the direction should be specified. For example, 20 meter towards east, 100 meter towards west, like that. So the displacement, when we talk about the displacement, not only the magnitude but also the direction to be specified. So when we talk about displacement, is a physical quantity which is having both magnitude, like 10 meter, 20 meter, like that, and directions, like north direction, east direction, like that. Unit is meter, but when we talk about distance, only magnitude is enough. We will not talk about the direction. If somebody asks you what is the distance, that indicate that what is the path length. When we talk about the length of the road, the direction is not required. The road length is 200 meter, 500 meter. So when we talk about path length, the direction is not mentioned. So when we talk about displacement, the direction should be specified. Okay, so this is about distance and displacement. Okay, the next is velocity. The next important term is velocity. Velocity denoted by V. The most appropriate term is instantaneous velocity. This is the most appropriate term, but in short form we say velocity. Instantaneous velocity. Velocity denoted by V. So the instantaneous velocity, in short form you may write it as velocity. velocity is equal to, listen, in short form, okay, in short form we may write it as displacement by time. Displacement by time, meaning that in 1 second how much displacement is there. In 1 second, how much displacement. Velocity means that in 1 second, how much displacement is there. In simple language we may write like that, how much displacement is there. That is velocity. Clear? I will give you example, don't worry, I will give you example. Velocity, let me write the unit first, after that I will give you one simple example. The unit is 1 minute. Okay, listen, the unit displacement has the unit meter and time has the unit second. The unit of velocity is meter per second. Actually you studied in the lower classes, but you must know the basics. So the velocity is displacement by time. Okay, I hope you have understood. Okay, for example, suppose there is a body traveled from A to B. It's an example. Suppose in 4 seconds, the body has got a displacement. Got a displacement means it is the shortest path connecting initial and final. Has got a displacement, say 20 meter. What is the velocity? The velocity is equal to displacement by time. 20 by 4, 15 meter per second. Okay, so the velocity is clear. So the direction is there because displacement has direction. So hence velocity also has the direction. For example, 15 meter per second north direction, like that. 50 meter per second south direction, like that. The numerator has the direction, hence naturally the velocity has direction. So the velocity has, let me write here, velocity has both magnitude, like 50 meter per second, 20 meter per second, like that, as well as direction. I mean north direction, east direction, like that. Please note it. It is 5 meter per second. 5 meter per second. So the next is acceleration. Acceleration is denoted by A. Let me write the definition first. Acceleration. Let me write the definition first. Acceleration is denoted by A. It is equal to change in velocity. Change in velocity divided by time. It is acceleration. Change in velocity divided by time. For example, let me give you one example. There is an object. Initially it is having a velocity, say 20 meter per second, meaning that in 1 second it will have 20 meter displacement. What that is the meaning of that? A body has velocity 20 meter per second means that in 1 second it will get a displacement 20 meter. Okay, it traveled during that time, some velocity has velocity is changed, and after some time After some time, it's an example actually, after some time the velocity now 30 meter per second. If you travel in a car, naturally the velocity will be changing over time. So the velocity is changed, suppose in a time interval, say 5 seconds. In a time interval 5 seconds, initially the velocity was 20. After that the velocity is changed to 30. The acceleration we have to find out. This is an example. If I don't provide example, you cannot understand the formula. Acceleration equal to change in velocity. Change in velocity means final velocity minus initial velocity. That is the difference. The final velocity minus initial velocity. That is change in velocity. By time, the change in velocity happens in 5 seconds. This is 10 by 5 unit. I will tell you right now. And another thing is, one more thing is, acceleration has both magnitude and direction. Direction I will explain in the next page. I will discuss the direction, magnitude and direction. When we talk about acceleration, we must specify direction, like north, south, like that. I will explain the direction. Definitely acceleration will have direction because the velocity, change in velocity is there in the formula. Velocity has direction, so naturally acceleration will have direction. I'll give you example after this. Okay, acceleration is a physical quantity having both magnitude and direction. Next, actually this chapter basically about the graph. Okay, if you go through the textbook problems, most of the question is based on graph and the directions of velocity, acceleration, like that. So let me explain more about the direction of velocity, displacement, acceleration, like that. Most of the questions based on the directions of displacement, velocity, acceleration, and there are so many graphs like position time graph, velocity time graph, like that. Okay, so note. Okay, let me give you one example about the direction. Okay, direction. So in this chapter we are dealing with the one-dimensional motion, right? One-dimensional means motion along a straight line. One-dimensional or motion along a straight line. Motion, we are talking about motion along a straight line. Straight line means the body will be either moving towards right or maybe moving towards left. You understood? Clear? So listen, let me draw a number line which can okay, so we can clearly explain motion towards right or motion towards left. So let this point be 0, representing the position of the body. Okay, to represent the position of the body, I have to mark some number on this road. Consider this as a road. What is this? This is a road. Think like that. One positions, I am marking what? I am marking just position. 3, 4, and from in the negative side of 0, you know, position -1, -2, -3, like that, -4, like that. These are actually positions. Now I'm just giving you example. Okay, this is just an example. It's a simple example. Okay, suppose there is a body here. There is a body. Initially a body was at 1. It has got a displacement like this and reaches 4. A body has traveled from A and reaches B along a straight road. What is the displacement? So this is an example actually. What is this? It's just an example. So if a body travel from A to B, there are plenty of questions like this. That is why I'm discussing this type of problem. The displacement will be the displacement is obtained by the final position minus initial position. In this way we find the displacement. Please note it. Final position minus initial position. Don't change the order. So final position is +4. Initial position is 1. I mean this is for AB. Okay, this is for AB. The displacement will be 4 minus 1, that is 3. Plus 3, understood? Plus 3. Because 4 minus 1 is actually plus 3. That's why. Correct. What actually means that the plus represents that the body has moved towards right. Plus sign indicate that the displacement towards right. Clear? Motion towards right. Motion towards right. So a body has got a displacement +7. +7 means that plus represents the direction, the motion towards right. Let me give you another example. There is a body, suppose it is here at O. There is a body, let it be P. It has got a displacement and finally reaches -3. There are questions in exercise, that is why I am discussing this. A body initially at P has moved towards left and Q be the final position. What is the displacement of PQ? Understood? For PQ, what is the displacement? Displacement will be the final position minus initial position. That order is very, very important. The final position is what? -3, correct? Final position is -3 minus initial position 0. It is -3 meter, centimeter, whatever. Okay. So clearly the negative sign indicate that the body has moved towards left. So the direction, I told you that the displacement has not only has magnitude but also has direction. The sign represents the direction. Clear? The sign represents the direction. So plus displacement has plus sign, meaning that the body moved towards right. The displacement has negative sign. Magnitude 3, that is okay. Direction is obtained from the sign. Negative, right? Negative sign indicate left side motion. So this is very, very important. Negative sign indicate the motion towards left. It's a fundamental thing. Okay, let me take the same example regarding, and remember, without any further example, right, let me write the note here. The velocity also has the direction. You agree with me? Velocity is in 1 second how much displacement. So without any numerical example, you please note it. If velocity is positive, then that indicate that motion towards right. Same rule applicable for velocity. Motion towards right. I will give you simple example, but I don't want to draw the diagrams for this. If velocity is positive, like plus 20 meter per second, plus 7 meter per second, that plus sign indicate motion towards right. If velocity is negative, motion towards left. So plus and negative sign is sufficient to, is sufficient for representing the direction of the motion. For example, a body has velocity plus 20 meter per second. What we can conclude? In 1 second, it will have a plus 20 meter displacement. In 1 second, the body, moving body, will have plus 20 meter displacement. Plus 20 meter displacement meaning that the body is actually moving towards right. Body is actually moving towards right. A body has the velocity minus 10 meter per second, meaning that in 1 second it will get minus 10 meter displacement. Body moving with the velocity, magnitude 10 meter per second and moving towards left. Or in simple language we say the body is moving with the speed 10 meter per second towards left. So the sign is very, very important when we explain the displacement and velocity. Both displacement and velocity, the positive sign indicate that the body is moving towards right. The negative sign indicate that the body is moving towards left. That's all. It's a very simple fact. All of it clear? Most of the students says that the acceleration is positive because the body is moving towards right, hence acceleration positive. That is wrong. That is wrong. Simply moving towards right does not mean that acceleration is positive. Simply moving towards right does not mean acceleration positive. Because I will tell you the reason. The acceleration has the formula change in velocity, meaning that final velocity, change in velocity means final velocity minus initial velocity, right? By time. Time does not have any sign. Time itself. Isn't it acceleration? Is it acceleration? Change in velocity by time. Correct? Initial velocity will be there, final velocity will be there. So the acceleration is positive only if you have memorized this formula, you can tell me. Acceleration is positive only if final velocity is greater than initial velocity. Final velocity greater than initial velocity. Velocity. I mean increasing velocity. If there is any increasing velocity, we say that acceleration is positive. But formally we say like that, final velocity greater than initial velocity. Final velocity greater than initial velocity, in that situation we say acceleration positive. Why? Because acceleration has the formula change in velocity by time. Change in velocity means final velocity minus initial velocity by time. So to check the sign of the acceleration, only thing is you just check whether final velocity, initial velocity, whichever is larger, you have to check it. If final velocity is greater than initial velocity, acceleration is positive. Final velocity larger means velocity is increasing, right? Final velocity is larger means increasing velocity, right? Increasing velocity. So in short form, in simple form, what we can say, if there is any increasing velocity, okay, this inequality you need not worry about this. If there is an increasing velocity, I can say acceleration positive. Acceleration will be negative if there is any decreasing velocity. Decreasing velocity. Velocity reducing, right? For example, a car is moving along a straight road, the brake is applied. A car is moving along a straight road, the brake is applied. The velocity is decreasing in that case. Acceleration is taken as negative. If there is increasing velocity, I mean speeding up. A car is moving, the speed or velocity is increasing. In that case, positive acceleration. So by simply looking at the diagram, if the body is simply moving towards right, that does not mean that acceleration is positive. A body may be moving towards right, but the brake might have applied. Understood? A body may be moving towards right, but brake may have applied. So brake might have applied. So the velocity is decreasing in that case. Body is moving towards right, that I agree. But if the brake is applied, the velocity is decreasing, or speed is decreasing in simple language. The velocity decreasing, in that situation, acceleration has a negative sign. If it is speeding up, I mean velocity is increasing, we say positive acceleration. So in this way we will find the sign. There are problems in textbook. I will discuss the problems in the next class. Okay.